We find ourselves surrounded by this vast and beautiful nature. Gazing up at the night sky dotted with stars and the boundless, vast universe. Since the birth of humanity, an eternal question has always lingered in our hearts. How was our universe born? In this science documentary, we will travel through the history of humanity exploration, journeying from ancient myths about the universe's origin and passing through the profound contemplations of philosophers to the brilliant discoveries of science, ultimately standing at the forefront of modern Big Bang theory. Our journey begins in the cradle of human civilization, filled with various myths and legends about the origin of the universe. In ancient Egyptian mythology, the world was originally chaotic primordial water. Amidst the chaos and darkness, the deity Atum created himself, thereby giving birth to other gods and all things in the world. The ancient Hindu view of creation depicts an endless cycle of the universe, where creation, maintenance, and destruction are managed by the three main gods, Brahma, Vishnu, and Shiva, respectively. This process repeats endlessly, representing the eternal cycle of the universe. With the rise of philosophy, people began to explore the mysteries of the universe with more rational and speculative thinking. 2,600 years ago, Thales of Miletus, one of the 7 sages of ancient Greece, declared that water is the origin of all things. Subsequent philosophers, such as Heraclitus and Empedocles, put forward their theories about the fundamental elements and origins of the universe. Heraclitus posited that fire is the essence of all things. On the other hand, Empedocles developed the theory of the 4 elements, asserting that water, earth, fire, and air make up the universe. He believed that the birth and evolution of the universe are the outcomes of the interaction among these 4 elements. Although these philosophical theories are still different modern science, they undoubtedly represent the first attempts of human beings to explain nature with rational thought. The modern scientific theory about the origin of the universe first came from the development of astronomical theories during the Renaissance. With the rise of humanism and the development of scientific methods, astronomers began to challenge ancient astronomical theories. For thousands of years, humans held the belief that Earth was the center of the universe. Polish astronomer Nicholas Copernicus, aiming to simplify the model of planetary motion within the solar system, proposed the heliocentric theory. This theory posited that the Sun, not Earth, occupies the center of the universe. In 1543, Copernicus published On the Revolutions of the Heavenly Spheres, fundamentally overturning the traditional cosmic perspective. This landmark publication is heralded as the revolution that not only transformed astronomy, but also the entire field of science, known as the Copernican Revolution. Building on the Copernican Revolution, German astronomer Johannes Kepler introduced the famous 3 laws of planetary motion, known as Kepler's laws, in the early 17th century. These laws not only reinforced the heliocentric theory, but also established a robust foundation for future developments in astrophysics and space science. Meanwhile, Galileo Galilei used his improved telescope to observe the starry sky. His discoveries, such as the 4 major moons of Jupiter and the phases of Venus, provided indisputable evidence for the heliocentric theory. The scientific experiments and observations of this period demonstrated the importance of scientific verification of theories. Isaac Newton's law of gravitation not only clarified the rules of planetary motion, but also revealed the universal force that causes apples to fall to the ground on Earth and the moon to orbit around Earth. Newton's theory demonstrated the universal interaction between all objects in the universe, tightly linking astronomy with math and physics, and profoundly affecting our understanding of the universe's structure and evolution. Newton's scientific theory provided a mathematical view of the universe. The universe was generally believed to be eternal, moving according to the law of universal gravitation. In the 18th century, French astrophysicist Pierre-Simon Laplace used Newton's theory to model the motion of celestial bodies and published the monumental work Celestial Mechanics in 1799. It is said that when Napoleon saw the book, he asked Laplace why there was no mention of God in his book. Laplace confidently replied, "Sire, I had no need of that hypothesis." Entering the 20th century, cosmology underwent a profound transformation, centered around the introduction of Einstein's theory of relativity. Relativity not only challenged the classical physics concept of absolute spacetime from Newton's classical physics, but also completely rewrote our understanding of the universe. The theory of relativity is divided into 2 parts: special relativity and general relativity. The basic assumption of special relativity is that in inertial reference frames without gravity, the speed of light is always constant. The general relativity, proposed by Einstein in 1915, is an extension of special relativity, introducing the relationship between gravity and the geometry of spacetime. Einstein reinterpreted gravity as the curvature of spacetime caused by the distribution of matter and energy. Based on the gravitational field equations formulated by Einstein, Russian physicist Alexander Friedmann was the first to derive a cosmological solution that suggested the entire universe might be either expanding or contracting. Concurrently, Belgian Catholic priest Georges Lemaitre derived a similar cosmological solution from the gravitational field equations and introduced the theory of the Big Bang. This proposal introduced the concept of a dynamic universe, challenging the prevailing notion of a static universe at that time. In the 1920s, U.S. astronomer Edwin Hubble's observations further advanced the development of cosmology. Hubble discovered the phenomenon of the expansion of the universe through the observation of the redshift of distant galaxies, showing that galaxies are moving away from us, and their speed is proportional to their distance. This discovery directly supported the notion that the universe is not static, but dynamically changing. Hubble's findings coincided with Friedmann's and Lemaitre's models of an expanding universe derived from general relativity, thus laying the foundation for the Big Bang theory. From the 1950s to the 1960s, scientists further studied the early state of the universe. George Gamow and his collaborators proposed the hot Big Bang model within the Big Bang theory, predicting the existence of cosmic microwave background radiation. The Big Bang theory describes the universe's origin from a singular, extremely hot and dense point approximately 13.8 billion years ago. Moments after the Big Bang, the universe was a hot, dense fireball of particles and radiation. As it expanded, the temperature dropped, leading to the formation of subatomic particles and simple atoms like hydrogen, helium, and other elements. As the universe continued to expand and cool, these particles began to coalesce under gravity, especially dark matter potential to form stars and galaxies. This is scientists' computational simulation showing the evolution of galaxies on a universal scale. Eventually, galaxies formed. Our solar system is located in the Milky Way galaxy. Let's return back to the earliest moments of the Big Bang. Astrophysicists believe that the primordial fireball of the Big Bang, over billions of years of cooling, would leave behind some residual signals. This is what is known as the cosmic microwave background radiation, a type of radio background that is almost uniformly distributed throughout cosmic space. The discovery of the cosmic microwave background radiation in 1965 by Arno Penzias and Robert Wilson offered concrete evidence for the Big Bang theory, as it matched the theoretical predictions of an afterglow from the hot, dense state following the universe's inception. The next major breakthrough in cosmology occurred in the 1990s, when astronomers discovered that the universe was not only expanding, but its expansion was accelerating. Scientists attribute this phenomenon to a mysterious force known as dark energy, which makes up about 70% of the total energy in the observable universe and acts in opposition to gravity. This groundbreaking discovery has revolutionized our models of the universe, profoundly altering our perceptions of its future and the ultimate fate of all cosmic matter. As research continues, the Big Bang theory propels further inquiries into the universe's mysteries. Explorations into gravitational waves, dark energy, and potential multiverses are pushing cosmological boundaries and refining our understanding of physics. Since ancient times, each theory and discovery has enriched our knowledge and brought us closer to understanding our place in the cosmos and the universe's ultimate fate. This ongoing quest not only feeds human curiosity, but also deepens our appreciation of the complex universe we inhabit. The astronomy documentary you are watching is a generative AI production by Snowboat Studio. Thank you for watching.